Good morning, everyone. As you can see, the classroom is still empty. And in this video, we're going to talk about tables. And as you can see, there are a lot of tables over there. Probably like a few hundred, because all of the classrooms have been empty. No, but we're actually going to talk about tables, but not those. Sorry for the bad joke again. So we're going to talk about tables, but not just any table. We're going to talk about some specific ones. And we're going to start with one that you might have already seen before. And that's this one. If we have, let's use 5, 10, 15, 20, 25. And down here it's 120, 240, 60, 480 and 600, for example. Then what you can see is whenever I add 5 over here, I also do the same thing in the next step. So if I'm looking at the change within the table, change is constant. And this table over here, whenever you have the same steps at the top of your table and at the bottom, it's called a, where I lost my marker, it's over here, this is called a linear table. The second kind, which I wanted to show you, is this one. Let's use these numbers 1, 2, 3, 4, 5, and let's use 10, 20, 40, 80, and 160. If you look at it like we just did, this is plus 1, plus 1, plus 1, plus 1. Then you might already think, okay, we have another linear table again. But then at the bottom, this is plus 10, plus 20, plus 40, plus 80. So at least something different is going on. And the difference is basically, if you want to look at this change and say something about it, we're not going to do that with the absolute increase. We're going to say we're going to multiply this with 2. To multiply this with 2. We're going to multiply this with 2. And again. And this table, whenever this increases constantly, and you have a multiplication factor over here which is also constant, so the multiplication factor is 2, which is constant. This is called an exponential table. Think about this next table. This one might seem more difficult, but hopefully it will make some sense. 4, 6, 8, 10, 12. And keep in mind, sometimes I'm only giving you part of a table, not the entire thing. I can give you the entire thing, but usually a part of it is good enough. And we're going to use these numbers, 800, 200, 50, 12 and a half, and let's see, 3, 160. Then the first thing which should come to your mind is, okay, once again, plus 2, plus 2, plus 2, plus 2. So usually there are no surprises at the top. Over here, it's minus, it's not plus. So that's also possible. Minus 150, minus 37.5 minus 9,716. So once again, there's something going on at the bottom. So what is actually going on? We're dividing with 4, or in other words, we're multiplying with a quarter times a quarter. Because multiplying with 1 over 4 is the same as dividing with 4. So once again, this thing over here is also an exponential table. Keep in mind, this table shows you exponential growth because it gets bigger, and this one shows you exponential decay because this gets lower. 2 more examples which I want you to think about. The first one is this one. 1, 2, 3, 4, 5. Sorry, I lied. There will be 3 more. Let's use 20, 18, 16, 14, 12. And if you like straight lines, then this video is probably hell for you. So the top it's +1 all the time. Over here it's -2. So the decrease is constant, which means that this table over here is an example of another linear table. The next one, table number 5. 1, 2, 3, 5. And we're going to use 1, 2, 6, 24, 120. Okay. Top +1. And outside someone's playing music. I don't know who. And over here you can see an increase. +1, +4, +18, +96. Well, obviously it's not linear. So is it exponential then? Well, we can check that. This is times 2, times 3, times 4, times 5. So this is neither stable, neither linear nor exponential. There is something going on, but what is actually going on will be taught to you in the 5th grade, I think. Last example, and this is not something that you necessarily have to know, but it might seem interesting to some of you. If we're looking at this table, 1, 4, 9, 16, 25, 36. What I basically did was I took the function x squared and then I filled in different numbers. And over here, increase is 5. Increase is, sorry, 5, 7, 9, 11. And the change of the increasing speed of the increase is constant. It's +2. And you will see this next year as well, that the change of the change, whenever you have a quadratic function, is constant. And this is a quadratic table, but you don't have to know that yet. I just wanted to show you that you could also look at it like that. So 6 tables. Hopefully you've learned what what makes them unique. And good luck with the homework assignments. This week there will be 2 videos, 8.3 3 part 1 and part 2 will come later this week, and then we will have an assignment about paragraph 1, 2 and 3, and I'm going to discuss that with you as well. Don't worry, hopefully, I think it's a pretty fun assignment. Hopefully, I actually don't know for sure. Good luck with that.